AI Frontiers. The AI Awakening Series Volume 2. Why AI Suddenly Exploded. Part of the Thinking Library. Part 1. The Overnight Revolution That Wasn't. In late 2022, millions of people experienced something that felt impossible. A student typed a question into a chatbot and received an essay. A programmer received working code within seconds. A business owner generated marketing ideas instantly. A teacher created lesson plans in minutes. Across the world, people stared at their screens with the same expression. How could a machine do this? The reaction was understandable. To many observers, artificial intelligence appeared to arrive overnight. One day it seemed like a niche topic discussed by researchers and technology enthusiasts. The next day it dominated headlines, workplaces, classrooms, and dinner table conversations. Investors rushed toward AI companies. Governments launched new initiatives. Business leaders issued urgent memos. Entire industries began re-evaluating their future. The suddenness created a powerful illusion. It felt as though a scientific breakthrough had happened in a single moment. But revolutions rarely begin on the day the public notices them. The reality is far more fascinating. The AI explosion was not the result of one invention. It was the result of decades of invisible progress, finally reaching a tipping point. For years, thousands of researchers had been solving problems most people never saw. Faster processors, better algorithms, larger datasets, improved neural networks. Advances accumulated quietly beneath the surface. Each breakthrough seemed incremental. Each improvement appeared modest. Yet history often works this way. A river may appear calm until it reaches the edge of a waterfall. Then suddenly everything changes. What the world witnessed was not the birth of artificial intelligence. It was the moment artificial intelligence became impossible to ignore. And behind that moment stood a convergence of forces decades in the making. Part 2. The three ingredients. Imagine trying to build a modern city. You need materials. You need energy. And you need a blueprint. Without all three, construction stalls. Artificial intelligence required something similar. For decades, researchers possessed ideas but lacked the necessary resources. The first ingredient was data. Machine learning systems improve by finding patterns in examples. In the early years of computing, data was scarce. Then the internet arrived. Every search query, photograph, article, video, and digital interaction contributed to an expanding universe of information. Humanity began producing data on a scale never before seen. The second ingredient was computing power. Even brilliant algorithms are useless if machines cannot process them efficiently. For years, computers simply weren't powerful enough. Then hardware improved dramatically. Specialized processors accelerated calculations that once required enormous amounts of time. Problems that previously took weeks could suddenly be solved in hours. The third ingredient was the algorithm itself. Researchers continuously refined methods for helping machines learn. Each improvement increased capability. Each advancement unlocked new possibilities. Individually, none of these developments seemed revolutionary. Together, they created something extraordinary. Data provided experience. Computing power provided speed. Algorithms provided learning. When these three forces converged, artificial intelligence crossed a threshold. The results began to surprise even some of the people building it. Capabilities that once seemed decades away started appearing much sooner than expected. The ingredients had finally aligned. The experiment was ready for its next phase. Part 3. The Deep Learning Breakthrough. One phrase appears repeatedly in discussions about modern AI. Deep learning. The term sounds technical, but the underlying idea is surprisingly simple. Researchers discovered that larger neural networks could learn increasingly sophisticated patterns. Instead of relying on shallow layers of analysis, systems could process information through many interconnected layers. Each layer extracted different features. Consider image recognition. An early layer might identify edges. Another might identify shapes. Another might recognize eyes, noses, or mouths. Eventually, the system forms a highly detailed understanding of what it is observing. This layered approach proved remarkably effective. Suddenly machines became dramatically better at tasks that had long frustrated researchers. Speech recognition improved. Image classification improved. Language processing improved. Translation improved. Recommendation systems improved. The progress was not gradual. In some areas, performance jumped dramatically. Problems once considered nearly impossible became manageable. Researchers began achieving results that would have sounded unrealistic only a few years earlier. Yet an even more surprising discovery emerged. When neural networks became sufficiently large, entirely new abilities appeared. Capabilities that had not been explicitly programmed began to emerge. Systems learned patterns researchers had never directly taught them. This phenomenon fascinated scientists. Larger models were not merely becoming better. They were becoming different. The implications were profound. If increasing scale could unlock unexpected capabilities, where exactly was the limit? No one knew. And that uncertainty helped ignite the next stage of the AI revolution. Part 4. The moment language changed. For most of computer history, communication between humans and machines felt unnatural. People adapted themselves to computers. Commands had to be precise. Instructions had to follow strict rules. Software often required specialized knowledge. Then language models changed the equation. Instead of learning the language of machines, people could use their own language. Questions, ideas, requests, conversations. Natural language became the interface. This represented a fundamental breakthrough. Human language is extraordinarily complex. Words carry multiple meanings. Context changes interpretation. Emotion influences communication. For decades, these challenges limited machine interaction. Modern language models dramatically improved the situation. They could generate coherent responses, summarize information, brainstorm ideas, explain concepts, and engage in extended dialogue. The experience felt different from traditional software. It felt collaborative. For the first time, millions of people interacted directly with advanced AI rather than encountering it indirectly through applications and services. This accessibility transformed public awareness. Artificial intelligence stopped being something hidden behind technology. It became something people could speak with. The impact was immediate. Students experimented with it. Writers explored it. Businesses adopted it. Curious individuals tested its limits. The technology reached living rooms, classrooms, and workplaces almost simultaneously. A field that had spent decades in relative obscurity suddenly became part of everyday conversation. And once people experienced the technology firsthand, the momentum accelerated dramatically. Part 5. The investment avalanche. History shows a recurring pattern. When a transformative technology demonstrates practical value, investment follows. Railroads, electricity, automobiles, the internet. Each triggered waves of capital, competition, and innovation. Artificial intelligence entered this phase with remarkable speed. Companies recognized enormous opportunities. Investors saw potential for entirely new markets. Governments viewed AI as strategically important. Universities expanded research efforts. Talent became highly sought after. Billions of dollars flowed into development. Competition intensified. Organizations raced to build larger models, better tools, and more capable systems. The pace of innovation increased accordingly. Breakthroughs that might once have taken years began arriving within months. New products appeared constantly. Capabilities expanded rapidly. This influx of resources created a feedback loop. Better systems attracted more users. More users generated more interest. More interest attracted more investment. More investment accelerated research. The cycle reinforced itself. The result was an explosion of visible progress. People were not imagining things. AI really was advancing quickly. But the speed reflected decades of preparation combined with unprecedented investment and attention. The world was witnessing the acceleration phase of a technological revolution. And revolutions rarely remain confined to one industry. Part 6. Why everyone is paying attention. Many technologies improve life. Few technologies influence nearly every form of intellectual work. Artificial intelligence touches writing, design, research, analysis, education, customer service, healthcare, finance, software development, logistics, and countless other fields. That breadth is unusual. Most inventions solve specific problems. AI functions more like a general-purpose capability. Its applications continue expanding as people discover new ways to use it. This explains the intensity of public interest. People are not simply evaluating a new tool. They are trying to understand how an evolving capability may affect their future. Will jobs change? Will education change? Will creativity change? Will expertise change? These questions reach far beyond technology. They touch economics, culture, politics, and human identity itself. The uncertainty creates excitement and concern simultaneously. Some envision extraordinary progress. Others worry about disruption. Both perspectives recognize the same reality. Artificial intelligence is becoming increasingly important. Not because it is perfect. Not because it is conscious. But because it is powerful enough to influence how societies operate. Whenever a technology reaches that level of significance, attention becomes inevitable. And AI has clearly reached that point. Part 7. The beginning of the acceleration era. Future historians may look back on this period as a turning point. Not because artificial intelligence was invented. Not because a single company launched a product. Not because one breakthrough changed everything. Instead, they may identify this era as the moment multiple forces converged simultaneously. Data, computing power, algorithms, investment, public adoption. Together, they created an acceleration unlike anything the field had previously experienced. The result feels sudden. Yet beneath the apparent overnight success lies a story spanning generations. Researchers who spent decades solving difficult problems. Engineers who built increasingly powerful hardware. Scientists who refine learning systems year after year. Their collective efforts laid the foundation for the moment the world now calls the AI boom. The explosion was real. But it was not spontaneous. It was the visible emergence of forces that had been building for decades. And if this period represents only the beginning, an even more intriguing question remains. If artificial intelligence advanced this far so quickly, what happens when the acceleration continues? Somewhere between decades of preparation and an uncertain future, humanity finds itself entering a new era. An era defined not by the sudden appearance of artificial intelligence, but by the moment its growth became impossible to overlook.